Hello, my wonderful Algebra 2 students. Today, unfortunately, I can't be with you, but we are going to be covering the information from Lesson 5 of Unit 2. So would you please open your books to page 99. Today, we're going to be talking about factors of polynomials and the zeros of the graphs of those polynomials. So I've got these three graphs here, and you can see that each one of them has the function written in factored form, right? So if this is a notice and wonder, some things that you should be noticing is that basically all of them have the same shape. They start low, go up, back down, and then go up high again. All of these have a horizontal intercept or an x-intercept of -1. All of them are crossing through -1 right here. And you should be able to notice in the function itself that I've got this factor of x plus 1 in all of them. Right? The fact that I've got that x plus 1 and I've got that -1 as an x-intercept, that should tell you that those are kind of going together. You could maybe wonder at this point why all three graphs look so similar. Maybe wonder why, like, this first graph ends up going so much lower right here than the other ones. See what might be coming from those factors possibly. And then maybe you should be at least thinking about or wondering about why the numbers and the factors seem to almost match the x and y intercepts, right? We have an x plus 1 in all of those, and they all have a -1 x-intercept. All right. So now that we've kind of looked at those graphs a little bit, I want you to just kind of fall back on our basic algebra skills. I want to think about what values make each of these equations true. So I'm going to use the zero product property. If I am multiplying several things together and I get 0 for an answer, notice all 4 of these, and there's more of them in your book that I'll have on the next slide, all equal to 0. So I want to know what's going to make each of those equal to 0. If you want to, you can certainly write out the equations for these, and on some of them maybe you'll need to. But for instance, in number 1, this is really saying that if I'm multiplying 3 things together and they equal 0, then either x plus 4 equals 0, x plus 2 equals 0, or x minus 1 equals 0. And you can certainly, never going to say you can't show your work, but most of you, I think, would probably be okay jumping right to answers on this. For instance, in this first one, I would subtract 4 and subtract 4. So x equals -4 is one of my answers. Here, subtract 2, subtract 2. I'm going to get that x equals -2. And for this last one, I would add 1. So I would get that x equals +1. Now, if you look at those, you can see that really what's happening is I'm changing the signs of the numbers that are either being added or subtracted with the variable, right? So -4 plus 4 is 0. -2 plus 2 is 0. 1 minus 1 is 0. So you can certainly write out all those equations. I would hope, though, that you could maybe just figure out in your head and write down an answer. And I'm perfectly fine with you doing that. So for instance, in number 2, I've got the same 3 answers that we start with. So this is going to be x equals -4, x equals -2, x equals +1. And then we've got one more here. And I hope that you can just see that that's going to be x equals 3 as that answer. For number 3, I have x plus 4, and then that whole quantity is squared, and x plus 2, and that whole quantity is squared. That really means that I've got x plus 4 times x plus 4 times x plus 2 times x plus 2 equals 0. I don't really need to have 4 individual answers here because this x plus 4 squared is going to give me one answer. Both times I would get that x equals -4. Right? Even if I wrote out all the factors. And x plus 2 equals 0, I'm going to get that x equals -2. So yes, there are things technically that are getting multiplied together, but really I'm only going to get 2 answers on that. We will talk more later about what that graph looks like and why there might only be 2 answers there as opposed to some of these other problems that get multiple answers. In number 4, the -2 that's in front, right here, actually doesn't do anything in terms of us solving the equation. It was like that -2 that factored out. I could divide both sides of the equation by -2, and that would just kind of go away. But there's no way that I can use that in terms of figuring out what x equals. I really have to be looking at the factors that have the x in them, included in them. So I would have x equals 4, x equals 2, x equals -1, and x equals -3, right? So I changed the sign on those last 2 compared to some of the other problems that we did. But again, it's just figuring out what would make each of those factors equal to 0. All right, here some of you may want to show a little bit more work. So for instance, number 5, if I've got 2x plus 8 equals 0, I can solve that. Subtract 8. 2x equals -8. I need you to not notice or recognize here that the 8 moving to the other side of the equal sign is really just going to change its sign, and then I have to divide by the coefficient. So I'm going to get that x equals -4 for that one. Some of you can handle that second one, the 7x minus 3 equals 0. That answer is just going to be positive 3 over 7, right? We're going to change this sign and put it over that 7. The third one is just going to be x equals 10, right? And if that middle one went too fast for you, feel free to go ahead and write out the work for that one. Number 6, I know how much everybody loves factoring. We get to factor this one. So I'm not giving it to you in factored form. The x squared is going to be an x and an x. Because this is, use a different color here so it stands out a little bit, because this is a negative or a subtracting 4 right there, that tells me that I'm going to have different signs. So one will be plus and one will be minus. Then I need numbers that multiply to be the 4, -4 really, and because they're different signs, subtract to be 3. Well, the only options for 4 are 4 and 1, 2 and 2. 2 and 2 doesn't subtract to be 3, so it's got to be 4 and 1. And because the 3 is positive, I know that I need more positives and fewer of the negatives. So feel free to multiply that together, FOIL it if you want to, so that you can check to make sure that we factor that correctly. But then I still have to solve this. Right, so the first one, x plus 4 equals 0, I would have x equals -4 is one of my answers. Then x minus 1 equals 0, that's going to be x equals positive 1. All right, in number 7, that x in the front is different than the -2 that we had back on number 4. This technically has 4 different things that are getting multiplied together and it equals 0. 4 different x's that are being used in here. So for this first one, what makes this equal to 0? Well, if x equals 0. The second term is not in our normal order, right? Usually we had the x in front for all the rest of these, but if you just think about this, 3 minus what number gives me 0? Well, that has to be 3. And then what number minus 1 is 0? That's going to be 1. And the fact that this last one is a decimal, I'm not too concerned about that, right? That should just be x equals -0.75. Okay, for number 8, this is not the same as number 3, where the square was outside the parentheses, so the whole quantity was getting squared. That x squared minus 4 is that sum and difference pattern that I have to factor first. So this would have to be changed into, I'm going to keep this x plus 9 over here. The x squared minus 4 would be an x and an x. Because it's a minus 4, that's going to be a plus and a minus. And it's a sum and difference pattern, right? It's a difference of squares. So I'm going to have a +2 and a -2. If I multiply 2 times -2, I do get -4. If I add those two, I get 0, which is why there isn't a linear term in that factor. I don't have just a regular x in there. But now I can solve this, and we do have 3 answers now instead of, I can only see 2 terms at the beginning before I got it factored. Once I have it factored, I actually have 3 terms. So I'm going to have x equals -2, x equals +2, and x equals -9. Okay. I know sometimes we don't do the are you ready for more, but this is a really good one for us, and it's something that's going to come up for us again. So this says write an equation that is true when x is equal to -5, 4, and 0, and no other values of x. So I want to go back to something that looks like number 5, for instance, right? I'm going to have 3 factors. And remember that when I'm solving these kind of problems, or actually I think that we should probably look at number 8. When I have 3 factors and I'm getting my 3 answers, notice that this was a +2 and I get a -2 here in the first term. In the second term, I had a -2 or subtracting 2, and I get a +2 here. +9 gives me a -9 for my answer. When I know the answers, they're going to be the opposite signs of what I see in the factors. So if I want x to be equal to -5, then I would have to have for my factor x plus 5, because if I put -5 in for x, I'll get -5 plus 5 is 0. And then I would have x, if it's a +4, I would want it to be -4, because again, 4 minus 4 gives me 0. And then this x or this 0 for an answer right here, I can put the x plus 0, x minus 0. I'm just going to put x in the front or in the back on this one, right? It doesn't really matter where that x ends up. I guess if I'm just going to keep it with the order that we've got there, I'll just do that. And that's equal to 0. All right, what if I have those same answers that I want, but it says no other values of x, but it's got to be a 4th degree polynomial. Not that I actually have to multiply it all together to get like an x to the 4th power, but there's only 3 answers there. And I don't want any extra answers. So to get a 4th answer, I just need to have one of these things be squared. So I would use it twice. So I would still keep that x plus 5 and x minus 4. And then the x, I could just write it as x squared, right? Or the x plus 5 could have been squared if the square is on the outside of the parentheses. Same thing with the x minus 4. If it's outside of the parentheses, that would work. Okay, if I was in class with you, I would actually be handing out a set of cards. I have all these cards ready, and it kind of makes me sad that I'm not there to just have you guys do this, but we're going to have equations or answers on these for what the x should be equal to, and either a graph or some kind of an explanation, and we need to match them up, okay? So let's take a look at this. So up on the top, those 8 cards are going to get matched up with card A, B, C, D, E, F, G, or H, right? So I want to be able to figure out which of these go together. And I know that we haven't actually been graphing ourselves, like graphing by hand, but we can still figure this out if we know what the zeros are. You need to understand that those zeros that we were just finding for what the x would have to be equal to is actually the x-intercepts, right? So if the y, for instance, was equal to 0, then I could solve this and say, well, this would have an x-intercept then at +5, at +4, and 2x plus 3 equals 0, so I would change the sign on the 3, so it's a negative, divide by 2, that's going to be -3/2. And again, I'm considering that instead of a y, that it's a 0, so that I can find those x-intercepts. Now, I need you to take a look at the options that we have there, and I hope that they're big enough that everyone can see them, I need either a graph or one of the descriptions that matches these answers. X equals 5, x equals 4, and x equals -3/2, which is really -1.5, right? I know that it's kind of hard to see, but card 4, this is at 5, this is at 4, this is at -1.5. So card 4 matches up with A. All right, for B, I would have that x equals -5, x equals -4, and x equals, this time, I would move the 3 over to +3/2. Okay, so take a second, look that over. Which of the graphs matches that explanation? Well, it's not one of the graphs. I shouldn't say necessarily one of the graphs, but one of the other cards. Card 6 actually has that. It says a graph with x-intercepts at -5, -4, and 3/2. So that's going to be card B. Card C, I need to move this up just a little bit. Card C is going to have x equals 5, x equals -4, and x equals -3/2. So I need 5, -4, and -3/2. And that's got to be card 2, right? So this one is C. For card D, finding my x-intercepts, I would have x equals -5, x equals 4, and x equals -3/2. Notice they're trying to keep those same numbers over and over and over, so we can have, we have to watch very carefully as we're doing this. So -5, +4, and -3/2. So we've got 2 of them in the negative part. That looks to me like this card 8. Right there's -5, -1.5, -3/2, and +4. So that's card D. For card E, we're going to have, I'm going to stop writing the x equals for all of these. I'm just going to write what the x-intercepts are going to be. So this would be at +5, +4, and +3/2. All positive answers. Well, card 3 says a graph with only positive x-intercepts. So that's going to have to be that one. All right, card F, I have -5, -4, and -3/2. Well, all negatives, right? None of my actual graphs show all negatives, but card 5 says a graph with only negative x-intercepts. So that's F right there. For G, we would have +5, -4, and +3/2. All right, we're kind of running out of spaces here now, so I've got 1 negative, 2 positives. The 2 cards that are left both have that. So +5, that's over here, -4, and +1.5. So that's going to be card G right there. All right, we only have 1 left, so hopefully this is going to work. We've got -5, +4, and +3/2. So we just flip the signs on those first 2 answers, -5, +4, and 3/2. So that's going to be card H. Okay. I know that probably went kind of fast, but I hope that everybody's okay with how that goes. All right, this is not in your book, but if I asked you to be able to write an explanation, if there was a student that was in class and we want to know about how to identify values of x that make this function, v of x, equal to 0. This looks like our volume functions, right? When we were making a box, it was 11 minus the 2 squares and 8.5 minus the 2 squares, and then the height of the box would be x. So this is a volume formula that we were using. Not formula, function. So for this, I would hope that you could figure out what would make each of those factors equal to 0. right? The first one, if I have 11 minus 2x equals 0, you could just add the 11 to, add the 2x. 11 minus 2x equals 0. If I would add 2x to both sides, I've got 11 equals 2x divided by 2. That's going to be 5.5, right? For the second one, 8.5 minus 2x. Again, you can certainly move the 8.5 if you wanted to. If I move the 2x, which is not kind of typically what we would do, I'll have positives. And half of 8.5 is going to be 4.25. And for the last one, x equals 0. Now remember, this is about the volume of the box. If the x is 0, if the height of the box is 0, it has no volume. It can't contain anything, right? If the x was equal to 5.5, that would make our length down to 0, no volume. Or if the length was, or if the width was 4.25, we would have no volume, right? Okay, today your homework is in your book, page 102 and 103. We passed page 100, yay! And you're going to be doing numbers 1 through 6. If you need any help with this, feel free to send me an email.